Okay, so Professor Jyotenendu Giri, thanks a lot for giving me time here for this interaction, and I also thank you for the lab visit. It is wonderful to be here, sir, and interact with you.
It is my pleasure. Actually, it's thank to your team also, you and your team, to come in here and then talking to us, and then it's convey the information to the others. That is really great work from you guys. Yes.
Okay, Professor, I happen to see the project, one of your projects displayed in recently held R&D fair in IIT Delhi, and we can see that is the DuroKea technology. That is, we will be discussing about that little later. I have some more points to be discussed with you. So I have prepared some kind of questionnaire. So if you allow me, I will start with one by one.
Sure.
Okay. So first couple of points are related to you and your academic journey. So I was going through your profile, Professor, and I found that you have done your graduation from University of Calcutta, and there is a BTech in Chemical Technology. And I found the year mentioned was from 96 to 99. That means it was in 3 years. Normally I am aware that BTech is only 4 years. So how come, I was getting curious, how come it was 3 years course for you?
Actually, that Calcutta University, there is this BTech actually, that intake coming from the after Bachelor of Science.
Okay.
So I did like the chemistry honors in the in Belur Ramakrishna Mission.
Okay.
With one of the prestigious institute. And after the honors, actually the top student, they have the option to get the apply for the this type of course.
Okay.
And then based on their mark and other things, they get the enroll.
Okay.
So where actually it was 3 years honors degree, where essentially you can understand the bachelor degree 3 years with the details in chemistry, you already done.
Okay.
Now the technology, chemical technology or chemical engineering, that is the exactly the applications of the science whatever you understood in the bachelor. Then that is actually visualize how it can be applied in the different area. So since we already done that bachelor degree, and that essentially that is technology aspect is reduced to 3 years. So that is a very interesting course, and that is really help to solve many of the problem in the chemical technology sector as well as the chemical engineering sector.
Wonderful. So now, Professor, after a BTech you joined PhD in IIT Bombay, and that was in Nano Biotechnology and chemical technology to Nano Biotechnology. So I want to know the motivation behind this particular shift from BTech to PhD.
Yeah, so that is after the BTech actually, I got the placement in the ACC Cement.
Okay.
ACC Cement, there is another division is called the refractory division.
Okay.
So since chemical technology specializations was the refractory division, so that actually I got the job placement in the ACC Cement, the refractory divisions. I worked there almost 1.5 years. And then we realized that I didn't like in that sense, because we realized that I really very focused on the something need to do for the research or development. So that way actually it was a good exposure. So how industry work and how industry environment. And then we left it, and then we appeared for the GATE, and then we got the admission in the IIT Bombay.
So that is immediately after BTech, Professor, right?
Correct.
So can you call it direct PhD?
It is all the IIT offer that direct PhD. But the things is direct PhD, since there is anything you enroll in the PhD, there is a coursework need to do. Coursework means this is the minimum credit coursework. Okay. So that coursework was as equivalent to the MTech. That is, it was, I can remember, it was 30 credit or something. So that equivalent coursework I did, but the only thing difference MTech and then or direct PhDs, I didn't do the MTech project there.
Okay.
So where actually I can save
some time,
and then we can directly start the research work.
Okay. Yeah. So this nano biotechnology, this matches with the chemical technology, sir?
Yes. So see, first of all, actually that you can see the nano that time when I pass out the BTech like 2000 like 1999. That time nano is the buzzword.
Okay.
Yeah. Now also there is just starting, the field has started. Many people actually, this is highly interdisciplinary. A lot of things actually, opportunities there in the biomedical field, and that is the where actually I got interested to go to the particular focus on the particular field. and that is the motivation I got, where actually is we can do something in the that field. So we got the admission or the focus on the research in the nanobiotechnology. Yeah.
Professor, during PhD, when you do PhD, we get very less such examples where a PhD student is a visiting research scholar. So you were visiting research scholar at Northwestern University during your PhD. I would like to know more about this opportunity as a visiting scholar, maybe because many PhD students, they will get benefited from your experience. And how can a student doing PhD, for that matter, can approach such reputed institutes for getting exposure to such labs? Because exposure during PhD, especially of foreign universities or labs, is very, very prestigious. So how could you get that?
Yeah, so see, this is the visiting the other lab, exposure to the other university, that's really help.
Yes.
Because particularly student which is not in that type of facility institute, so for them basically it is help. And then when during my PhD, is the around 2000 to 2004 or 2005, that time there was limited, there was not that much fellowship which support to go to the abroad for doing a PhD. Only I can remember there was that fellowship was there. I didn't go because it will be in between your PhD, so that way actually we didn't go. But there was a later actually there is a collaborative work.
Okay.
And then I was student with Professor Bahadur there, and then that actually the Professor Bahadur has the collaboration with the Professor Vinayak Dravid, who is in Northwestern University, is the Division of Engineering.
Okay.
So there actually the collaborative, and then I went there for part of the work to do there. And so that it's get the exposure to the particular, that is a very nice university, and then we got a lot of state-of-the-art facilities, and then work with the student with working in the nano materials, so that's a good exposure. But now actually that is the scenario change. Scenario means now you can find out many fellowship. Government, from the efforts came from the government. There are many such fellowship where actually PhD student can go for the taking the fellowship, go for 6 months, 1 year. Many such fellowship is there where actually the government promote that you can find out DST also support, ICM also support, and ACRB also support, DBT also support. So many such fellowship is there. Like the institutional level also there is a collaborative efforts. So that is now the student has a lot of opportunity.
Okay. So and they should avail it also.
Correct. Yeah. So that definitely it will. There is a positive part. There is also since if you go there any of the lab, let's say you invest 6 months or 1 year.
Okay.
So then there actually definitely you go to the other lab. You cannot start immediately working. So you have to have the buffer time and things. So that part actually one of the things you may lose few of the months actually to get the outcome. But exposure wise definitely you get the good exposure.
And Professor, after PhD also you continued with your research in universities, and to mention the most prestigious institute, California Institute of Technology, that is one of the best institute globally. You did your postdoctorate from your California Institute of Technology. We want you to share your experience of your postdoctorate fellowship in Calitech, and also tell us how to get postdoctorate fellowship, because there are so many PhDs who aspire to be in such places, but they are not having much awareness about that.
Yeah. So that is one of the advantage I got the Northwestern visit.
Okay.
So what happened, like because this type of institute, there is top institute, and then normally the student when they do the interview other things, so they prefer like if you go meet and then directly interact, that is more effective way to do. So when I was in US that time, actually I got the opportunity to go there, present my work, as interact with the faculty. That way actually I got that fellowship, and that university, Caltech, is the amazing university. That. Because I was working the postdoc in the division of chemistry, chemical engineering, with the collaborations with the division of biological science and bioengineering.
Okay.
So that is the interdisciplinary project where actually I work with nano material toxicity. There's a great exposure, and then my postdoc supervisor was Professor Bill Goddard. He's one of the one of the top-notch scientists in the computational field. And then also there is when I was the postdoc, that time the group member of Professor Bill Goddard was 70 people. You can imagine, since big people has this abroad actually a lot of students there, but there is a many postdoc was there. So where actually that is a good exposure. And then also the biological department where actually bioengineering, where Professor Scott Fraser, he is the development of biology. So then I got the very good exposure, the interdisciplinary exposure, where actually my PhD started with nanobiotechnology, which is the highly interdisciplinary. My base actually it is chemistry, and then chemistry, then it's come to the chemical technology, the applications. Then we get the more exposure is nano, and their biomedical application. Then we go to the Caltech and give the another set of like the different exposure to the different department, and the project was the very high interdisciplinary. It was really great place to enhance my expertise and experience. And from there actually, once I've been there for 2 years, then we applied National Research Council called NRC, Joint Postdoctoral Fellowship. It is the open for the all over India, all over world. Now they support few of the postdoctoral fellowship, associate fellowship, which is a joint postdoc supported by the NRC, then joint postdoc of NIST and NIH. NIST means National Institute of Standard Technology, you might have known that. And then NIH is the National Institute of Health. So that is another opportunity where actually I started working with the fellowship, the 2-year fellowship. I working in the NIH as well as the NIST. So that is the another opportunity we get, like the NIH, that there was my supervisor was there, Professor Pamela Ruby, which is the stem cell biologist, and then NIST was the Mark Cicerone, he is the physicist as well as the chemist. So that is where actually we.
So Professor, you were getting very good opportunities there after postdoctoral fellowship also, like NIST you mentioned, and American Dental Association in Maryland you were working. So comfortable life, stable career over there. So what motivated you to come back to India and join IIT Hyderabad?
So once I end the NRC fellowship, then I got the job opportunity in the American Dental Association Foundation. This is the research foundation, which is basically, you can see this is the many of the stamp come in the all the toothpaste. So that is the ADF. So that is where actually they do the research for the dental or related periodontal lesions and other things. Where actually I joined as the staff scientist, and so it was a good facility, good job, everything. And then, but always I feel that there is something actually I am working with for someone. So we do everything, but at the end actually we do the work for someone, and then we feel like some sort of very you're tight. So you cannot do anything. You don't have that freedom to do yourself, to do for something for our country and other things. So with that point actually. I got married, and then my wife joined. She's a doctor basically. She got clear the USMLE. USMLE is the one the exam. She's the pulmonologist, and she joined there. And then that time it was very uncertain. What will be there, like where it will settle and what will settle. Then she also started preparing, and I see this is another tough job, tough exam. So one chance actually she also got clear. Now. That point actually we are very much struggling what to do. So because my motive was we'll come back India and do for something actually, we'll do work for own and then develop something which is very useful for the society and for India. So that is the one motive was there, and that is in my mind actually I always keep on. And then that point actually, though she's clear. But I applied for because that is the transition where actually we are exploring every places. Then I got the offer from IIT Hyderabad, IIT Chennai. Then that point actually, whether we will come or stay, that's the last chance to come back to India. And that point actually, I very much thankful to my wife, Dr. Vaishaki Chandra. So she supported. Means instead of saying that I clear it, I want to stay, because for her that is one of the best place to
Yes,
so practicing on things. And then she said like, okay, whatever you feel that, if you feel that you are going back, it's you need to go back, and then I'm with you. So she said, okay, we jointly decided. It was very tough time to decide what to do. Then we left the job, and then we come back to India, joined in IIT Hyderabad, and then it was 2013 September, and then we joined here. We started our own research group development.
So Professor, you said you got IIT Madras also. So not joining very old established IIT, then why IIT Hyderabad?
This is personal choice.
Okay.
There is many things actually.
Yeah, I understand. So Professor, now related to R&D fair. I mean, first ever R&D fair was conducted in IIT Delhi, and believe me, this was a really very good initiative, and I only hope that such things happen every year. So there were 75 projects, pan IITs, 23 IITs participated. One of your projects was also displayed there, and the name of that project is DuroKea technology, if I am pronouncing it correctly. We want you to tell us about this particular innovation, and we have kept certain things here also related to this technology. So it addresses the problem of patient acquiring healthcare associated infection. So we want you to elaborate what these healthcare associated infections are, and if you can mention some of such infections. Yeah.
So that is DuroKea technology. So DuroKea means its name says DuroKea. Kia is the word which is Kia means care.
Okay.
And Duro means duration.
Okay.
So that is the name tells you that we developed products which has the durable care.
Okay.
So there actually it was the fair, IIT R&D fair was really good. It is the platform. There is a nice platform to showcase the technology to the industry people, to the different people, and that was really helpful for me as well. And it's very effective. I hope that there should be many more similar type of events. This is started. Just future, definitely there will be many more events for them.
Yes.
And starting that DuroKea technology, we started our research during the pandemic. Pandemic time, you can imagine there is suddenly it has started the lot of scarcity of sanitizer.
Sanitizer, yes.
So the moment the lockdown happened, what happened? That is because that point actually, you can the beginning of the lockdown, you can see there is a most of the people does not know also like the that is what is the sanitizer.
Yes, yes.
Then suddenly actually it was the
huge
lot of demand.
Yes.
Then we started one initiative in IIT that is to supply the sanitizer to the surrounding hospital.
Okay.
Surrounding Sangareddy, collector office, so that they can distribute to the different. So we started that the initiative taken by Professor Murthy, and then we started, and I was the in charge. We used to make the I think 500 liter every day.
Okay.
Sanitizer, and then we supply to the different hospital
in our labs.
Is IIT. Then because that is this sanitizer, since our lab actually every day when do the sterile work. We used to do like the sanitizer because we always clean our hand and use the surface cleaning. That is the normal alcohol based things actually we have been using.
Right.
That time actually I was the lead and taking the leads, and I was the producing this much volume and distributing the thing. And then that point we feel that look, this is the how many times actually you do sanitize, because if you go out and then you touching one place, you have to sanitize. It is absolutely very inconvenient. You cannot do it. So that point is like there is a feel like is something. Why not something we develop one time application and then let's give the production for longer. And then that is required for surface, the hand and everything. That is the transmissions of that COVID virus. I started to, because my lab actually is a nano biotechnology, like nanomedicines, a lot of nano science and technology, biomedical. That is everything is there. We started initiating and then searching what we started the research. Then we developed the formulation, we filed patents within 1 year actually. It started like the COVID started I think 2019.
No, 20 March.
20 March. 20 March. Then 20 March by December actually we developed formulation, we filed the patent, everything, we started field trial, and 2021 April actually we launches the product.
Okay.
Now that is the where actually then there is a lot of application is there, not like the personal hygiene. So if you go to the any hospital, what you find that, so hospital actually one of the source of pathogen. So you can that any patients, like the let's say patients go with some sort of disease which is not the infection, then they get the infected from hospital. So the percent of infection, you'll be surprised, it is the more than 20%. Normal if you go to the visit the hospital, there is stay for few hours, there is chance to get the infection from the hospital is the 20% people will get infected. Now this same patients, when we admit to the ICU, there is up to 60% patients get infection from ICU. So that infection is the bacterial infections, is the infection from the viral infections. So many things, many infections. So these pathogens, it's the source is the hospital environment. So that infection, it will call hospital, like the healthcare associated infection, HI.
Okay.
Is the huge burden. Is almost $60 billion worldwide spent to tackle this HI. So what HI do? So it's readmission, increase the readmission of the patient. Because patient, let's say patient admitted ICU for some surgery. Let's say now that during stay they get the infection, the bacteria infection, other pathogen infections from the hospital. Now that increase the stay in the hospital. Not only that, the most of the pathogens which is let's say drug resistant, the antibiotic resistant pathogens. Now normally we have the few antibiotics only. So many of the pathogens exist in that hospital environment. They are multi-drug resistant. And then even that pathogens actually that's the mortality rate of that HI infected patients. 20%. More than 20% patient will die. No matter whatever you do. Like the within 100 patients infected HI, and then 20 patient actually will die. So that is a huge burden, and that is exist. And to overcome this, there is a protocol to how the HI happen. So let's say some of the patients actually get infected with some pathogen. Now that patient surrounding, because that pathogens will be come out from the outside body, like your biological fluids. Also that let's say equipment, some biological fluids sprayed surrounding the surface. Then this surface actually that healthcare worker touch with the patients, that hands contaminated. Now that surrounding surface from bed and whatever you can imagine, and that pathogens will contaminate and stay for many days. They can survive for many days. Then that essentially transmit through the healthcare worker. And also you can many of the when you go to the ICU hospital, same equipment they use from one patient to the another. It's a common equipment. So that also the patient which is infected, then the same equipment actually it is next. Then that way transmission happen. So surface, hand surface, then different surface, that is the where actually transmission or that spreading is happening. So because there is a protocol to clean the surface, there is a trenching protocol, but it is I don't know how many people are following it. It's very difficult to follow because how many times you clean up, because conventional whatever disinfectant and then cleaning products, they don't have the long lasting action. So once you clean up, that moment is clean, that surface and hand and other surface, your instrument surface, floor, everything is contaminated immediately. Now there is absolutely difficult to 100 times cleaning in that type setup. So that is the where actually that HI never stop. Now keep on growing. And what happened? Let's say some hospital facility, there is that some bacteria is not multi-drug resistant. What happened? Same bacteria, when they rotate 3 of the patient body or few of the patient body, there your same patient actually, let's say patient A, patient B, patient C, that is actually you have to use the antibiotic. Now one patient actually they that bacteria actually they interface the antibiotic. The another patient also similar. After few turn, that pathogen become multidegradation. So that is exactly happening in the healthcare sector. So what we thought of like the all possible surface and then where the pathogen transmission happening, we make the surface self-disinfecting. That means one application do and that surface keep on disinfecting. That is the best possible way you can control the thing. Where the DuroKea actually we develop. We develop many of the all possible different products, which is the 4, 5, 6 or 7 different type of products for the different surface possible surrounding hospital environment and hospital surface, where the all surface becomes self-disinfecting. One application. Yeah.
So when we say self-disinfecting, what is the meaning of that, Professor?
So let's say your I'll give the example. Let's say your hand. Now you clean up. You use the hand sanitizer.
Right.
Now hand sanitizer, conventional hand sanitizer, what is content? Alcohol. Alcohol actually it is instantly evaporate. Alcohol is a killing agent. So you apply the hand sanitizer in your hand. That is basically the moment you touch the alcohol with the pathogen will kill, and then that moment actually your hand is clean. Now you are not sitting ideal. You are touching some patients and other things. Again contaminated. Now how many times you sanitize your hand? The similar way of surface also. Maybe one day actually maybe 1 time, 2 times they clean the surface, common surface and other things. Then that is basically absolutely that is again very contaminated. So that self-disinfecting means our product actually or the self-disinfecting type product, they make the coating on the surface. So the coating has the capacity to kill. So any further once it's coated, then any further pathogen come in the form and then instantly kill. That is called the way of self-disinfecting. The hours or days you can keep the coating. As long as the coating is there, the surface keep on cleaning.
So I was going through this, Professor. These are a couple of products, and it is also written that it kills 99.99% of the germs within 60 seconds. That is mentioned. So how could you compare its effectiveness to other hygienic products which are available in the market? Because there are other sanitizer. Though you mentioned a little bit about that, so you must have done that comparative analysis and comparative study also vis-a-vis your product.
Correct. So this this all the even conventional also the people claim like the 99.9% they kill. The question is conventional one they kill instantly and then after that there is no effect.
No effect after that.
Now here actually you kill as well as they keep on killing.
Okay.
That is the major difference. So that is the surface become they make the coating and then the surface become disinfectant, self-disinfectant. That is the major difference.
So you mentioned that the surface it forms long-lasting nanoscale coating, which remains up to 35 days and prevent other bacterial transmission, leaving behind any other alternative that is available in the market where such kind of things is available. So how does it stay so long on the surface, Professor?
So basically, see, this is the one things we included many of the very interesting three interesting science here. So conventionally, actually, even long-lasting this type of products, if you go to the abroad, some of the companies before also exist, now also there. These people commonly use the sealant, quaternary sealant. So where actually the sealant is a polymer and attached on the surface and then that keep on cleaning. Now the sealant product actually it has the some sort of advantage disadvantage. So this is where actually takes the a longer time to kill and other things. Where one of the objective was the instant killing and the so there actually what we use instead of sealant polymer we use the nano particle system. So this nanoparticle has the property to adhere on the particular surface. So we have the 7 different products in the different formulation. So then the particle has the capacity to adhere on the surface in the specific surface. Okay. So that adherence actually it is the play with the chemistry. Now the killing actions we use the 3 individual killing actions. One actually that is the nano, the particle if you spray on the surface, that make the nanoscale roughness. One. Second, actually, that also surface have the some sort of molecular needles that create the some sort of needle structure on surface. Nano roughness, on that also molecular needles is there, and another actually the release of the some of the molecules which is encapsulated. Three together actually they kill very effectively, very fast way the pathogen. That is the where actually this is the first killing mechanism one. And it stay 35 days particular surface in the particularly dry surface things because the particle property is like that. So it will stay. It will stay for the bind such that it will stay after 35 days.
So I can see couple of things here, Professor. Different things are kept. What is the difference between each of these bottles?
So we have. So let's say if you considering the HEI transmission or spreading of the pathogens. So there is, you can visualize the all possible surface surrounding the patient. And then during the hospital environment, what is the possible surface where the pathogen stay and can live, and what is the how they are transmitting or the spreading. So if you consider the any of the patient bed, there is a surrounding, there is a patient bed, there is chair, the patient bed itself, there is a fabric, there is metal or wood, there is chair, table, and then there is a floor, and then healthcare worker the only touching through the hand.
Yes.
And also you can see the instrument. Right. Instrument. So these are all the possible surface where actually pathogen can live or pathogen can contaminate it, and pathogen lives and pathogen the transmit. So based on the different surface, we have the DuroKea H, which is the hand sanitizer.
Okay.
So DuroKea H, where actually one application is make the coating. It is alcohol based with another formulation.
Right.
It make the coating on the surface, and then it's up to cleaning your hands up to 24 hours. Now when we developed that, then we found that we thought of like the many of the people have the allergy with the alcohol. So then we need to make the particular kit. Kit actually the alcohol is not good. Or many of the adult also they have their alcohol sensitive skin. Though our product actually we don't have to use the again. So but still alcohol actually we want to use. So we make the another formulation where actually remove the alcohol. It's a foam. This is called the DuroKea H aqua. This is the where actually you can see that there is absence of alcohol, but it has also long lasting effects. So one application is a foam, water based, and that is the one application up to clean the hands up to 24 hours. The H. Now the next is DuroKea S for surface. So this is the alcohol based formulation, this one, and then here you can see this is the one spray. You can spray in the hard surface and soft surface. It make the coating on the both surface, and then the coating can stay up to 35 days. And then that is where actually surface actually it's not. Now many of the hospital, you go to the hospital environment, and then you can see the doctors, nurses, they wear the fabrics for the surgery room and then also in the ICU. So fabric also there is another possibility how to carry the pathogen. So we make the DuroKea, which is the fabric sanitizer, where actually you can make the fabrics, spray on the fabrics, and that fabric surface becomes self-disinfectant. So that self-disinfectant property remains till you discard the fabric or wash the fabric. So and then the next things come in the equipment surface. So equipment surface normally people do the regular everyday. So we have the clean and spray and wipe. So where actually essentially you clean the spray on the equipment, all equipment surface, whatever possible equipment, and then wipe it and then make the coating. It's up to 24 hours. Up to 24 hours next day you can clean the things. Now the next last one actually this is the floor. Where actually you can consider the any type of this facility like the normally our home also we do one day daily once. Yeah. So there actually we also it is 24 hours. Once this is the work as a regular floor cleaner, you can dilute it in the water and then you can mop it and then make the coating on there, and then it's up to give the clean surface up to 24 hours. So this we develop the all possible surface specific formulation to stop the spreading of the pathogen.
Okay. Professor, I have two questions to ask you on the basis of this. Number one, the kind of disinfectant or kind of things we were using during COVID, that was only to hand sanitize. So which among these is used for that hand sanitizer?
So this is the H. The
H1.
H and aqua both are actually.
So H in hand, and that is how we
and H aqua, which is the alcohol free. So this is for the, as I said, the alcohol sensitive. This is the H.
Okay.
And that also that you can remember that time actually the surface was the door handle and other things actually that is used to keep like the, you know, that is surface also that is we used to that time also we reached to the product reached to the many of the household. Okay. So we use the two products.
Okay. So Professor, my next question is related to its usability. So we don't expect a person to go in shop and purchase all these things for different applications. Whom are you targeting once this product comes to the market? Whom are you targeting, and how do you see this, entire commercialization of all these things?
So we already commercialize.
Okay.
We already commercialize because this product actually, I think that you can 2021 April.
Okay.
Our Ministry of Education.
Okay.
He launches the product.
Okay.
Through the IIT and we build presence in the different e-commerce product.
Okay.
So like our Kia Biotech, this is one of the company which is marketed. KiaBiotech.com, also the Amazon, Flipkart, all their presence. And they basically this have been people are buying for their personal hygiene. Now two of the products yet to come in the market, where actually the which is the floor cleaner, actually is the instrument. That is actually we finalize we just testing, we tested everything. Now we're actually waiting to bring to the market as well. Other product here, so far actually we target to the personal hygiene. Now we targeting to the hospital sector. This is the huge button. So as long as personal hygiene concept, this COVID already is about to go, and then people also still have to use for their better health and things. But this is the major sector where actually hospital, the healthcare associated infection actually remains the huge button. So where actually next our target actually to overcome that.
Professor, you already mentioned that it was launched by then Education Minister. So your product was launched as world first affordable and long-lasting hygiene product by Education Minister that time. So what are your views? Why so long a gap in getting this kind of thing earlier? And what other researches were done in the same direction by other companies? Because you thought of it, you thought of the ideas, but it is so long that this product has come up. So what other companies what is the situation of other researchers in other companies related to this particular domain, and how do you compare your product with your competitors or other companies which are having similar kind of products?
So first of all that our product, one thing we can notice, this is we make it affordable.
Yes.
One.
Yes.
And then also it is effective, and so this is the two major things any of my research development we consider. We target the affordability. That is one important things actually are considerations. Affordability means if you consider the product, similar products abroad, there is and that their presence for the last 5 years. There is some company abroad also, particularly US based. Now India there was nothing.
Okay.
And even if you abroad product you consider, it is very expensive, and that is the different technology, and that but we cannot afford it.
That's true.
So we made the similar or superior or similar products. Then it is a much affordable price. So which is the very important for Indian community, Indian scenario or developing country. So that we made it. And also the Indian year, if you consider India, I think there is the similar product is not there, and some of the things actually which is the inorganic particle based silver and the titanium oxide is some of the company startup come up. But this is our actually entirely all the possible different surface and different surface we have product which is very much affordable and effective.
So when you said affordability, Professor, I would like to mention two things which I understood from your products and from your website. Affordability in terms of cost also, because it is rupees 189, that is what I could write here on the basis of the information available. And second, also in terms of quantity. So quantity required to sanitize particular space, that is also affordable, and cost is also affordable, and it's a wonderful product, Professor. Now I'm coming to your journey. Your journey started with one startup, which is EFOCare, if I am pronouncing it correctly. Yeah, EFOCare, which was incubated at IIT Hyderabad only. And then you collaborated with a company named Kiev Biotech. And could you give us some insight about the business model? How did you plan to get your product from lab to market? Because now we can see the visualization of the product is also there, from ideation to visualization of the product. So what were the major challenges and what was the business model behind all this?
Okay. So some of the things actually I need to find out the affordability. So when we have the problem, then we may have the many solutions.
Right.
Now, if you consider the affordability, among the different solutions, you have to really carefully choose the particular one which give the low cost production. So there, any of the technology we are developing, the main focus is affordability, because our Indian scenario, affordability is very important to reach that. And as I said, one of the motivation come to India to do something for the society. And their affordability, because is a very important factor. So in case of this product also, we there may be different possible solution was there, but it takes longer time. The product cost will be the high. So there we choose the particular science, particular material where actually it give the shorter span to get the approval, actually to get the that is the affordable products, like the price cost. And then when I started my lab and things, and then that is our lab now. You have seen the lab is the main focus on the 3 area: tissue regenerations, and then nanomedicines, and then fundamental machinery. Now that many of the problem we work where we really need, because I will come to there, we really need the solution, which is the affordable manner way. So one of the things is here, this is there, and there if you now if you see that if you compare in the abroad scenario and Indian scenario, there is a big gap between industry and education. There is a different reason, I don't want to go there, but the gap actually is the what is the effects of the gap? What happened? We do research, we do development, but it's remain in the patents. It remains in that confined in the lab. We never go to the market. So now the government also, there is a lot of motivation, a lot of facility, like they are facilitating that type of like a lab to market, and that is a lot of initiative, good initiative taken. And that initiative actually, if you want to, I realize that if you want to do bring the products, if you research to the particular common people, which is my main objective, coming back from abroad things, and that is definitely you have to take a lead. Otherwise, there is I develop technology and wait for the industry when they come and take. Since that ecosystem not show for exist, that is really long way to go. Then definitely you have to take the initiative to take your technology to the market. So where we started the keeping that considerations, and then the experience, and then what is the drawback in the current scenario. Then we first actually we make the one startup is YourPedia. Because you can see my main expertise in the research. Now we do a lot of good publications, patents, and then also we technology which is can be commercialized. Now to take that considerations, we establish the YourPedia innovation, where actually we also the motivation was we do the whatever lab we are developing, that actually will do further, that company for then you do further to get the next level to go to the market. Now product development, getting approval and bring it to the market, that is the one stage where actually I can do, but my expertise actually, whatever expertise I got, I can easily can take to. Now next actually challenge is, once this go to the market, there is a different ballgame. Because there is the things remain the marketing. So where actually I don't have that experience. Or if you consider the entrepreneur, so I have I am learning. So where we have separated out that looks IIT has it take the leads to get the product up to market. Now when you take to the market, there is we need some help from the other. So where we Kia Biotech, we take the help from the others where they can help to the reaching the product to the different. So that way actually we develop the two. I am the co-founder also Kia Biotech. So then that way actually Kia Biotech other people can help to bring the product to the spread the product market. So that is the model I follow typically, and where actually the IIT do all the development. After development, that is all the remaining work to bring to the market.
So that is wonderful, Professor. And being sitting in the ecosystem of academic institute, if you become co-founder of a company and you bring it to some good level, that is really wonderful. Professor, now my next question is again related to students, so many students. I visited your labs and I also saw the products which you are making, and I even interacted with your students. So my question to you is related to your research areas. Whosoever will be listening to you and want to work in this particular field, so can you suggest some recent, latest research areas in which students should focus and where they should channelize their research energies and where they should go?
See, this is entirely depend on the what student need. Let's say not immediate. Let's say a couple of years after that, finishing that particular course. So some student they need to go for company, higher study, postdoc. So definitely there for them actually it is very important to have the good publication.
Right.
Now the my lab also I do, because I am first actually my entities and the professor in IIT Hyderabad. So where actually we have to do a lot of research where actually it give the good publication, and then so that student get those student they are very much interested to get the good publication and then get the boost to the future career. So for them actually definitely I have to be very sensitive, and we do that way. And some student they are, let's say they are very focused on the particular become entrepreneur. Now for them it's a different. For them the publications is one, but they are basically they need something actually they want to become entrepreneur and interior. So that problem actually we need to find out the problem which is really help them to become entrepreneur. So where actually we found the problem where all are important. The question is which is the needs, which has the social needs, and then so that the technology is helpful to the many, and then you can start the both parts. So my research also focus the similar way. We do the research where actually get the good publication, and we do the research which is also very much the technology is beneficial for the society. So both way actually we do, so that depending on the what student need, we can work in the different direction.
Okay, Professor, I interacted with so many students in your lab, and I wonder what do you see in your prospective students when you take them under your mentorship, like masters or doctorate? So what do you see in your prospective students?
See, this is if you consider the PhD student, so PhD is the degree where actually is a degree is very important to where people look your CV. CV means like how many publications you have, how good the publication are. The publication will come only for work. If you do work, the publication will come. So essentially the students should be sincere, hardworking, and students should have the interest to understand science or find out the science. So these are all the very important criteria for any of the PhD student to become good PhD student, because your good PhD student is only defined if you have the many page of CV. That means many page of publication, lot of publication. So there actually it is very, I think I expect also, and that is also good for the student for their huge public outcome. So students should have first important things is sincere and then hardworking. That is one, and second actually the things is the The brain actually, see, this intellectual, and then how good your because that you have limitation. But whatever people come, if they are hard work, they can overcome also that limitation. So that way actually PhD student is very essential criteria to the good student. Actually you have to be hard working and sincere, and you have to the fashions, or you have to understand the science so that is one criteria. And MTech also people that based on that taken. MTech actually student what they want. If they want to be entrepreneur, if they want to be go for the PhD, that is also again decide like what supposed to be. But the essential common criteria is students should be sincere. Students should sincere to study, sincere to learn, sincere to work, and so that they can get the better, they can get the best, they can get the best opportunity and best way to learn, and then so that the future career.
Wonderful, Professor. So Professor Giri, I think I have come to an end of this wonderful session then. So I am really thankful to you once again at the end of the session. Not only you answered all my questions, but this is the additional thing which I did not expect, but you have displayed this also, and wonderful product, sir. I wish you all the very best for your future endeavors and all these things, and really thankful to you for time you spared today. Thank you.
Yeah, this is also very much thankful to you to come from all the way Chandigarh to here, and then get the lot of informations about my research, about the products, and then it will help to the others. So surely. I think that is a good initiative. I thank you and your team.
Thank you, Professor.